All right, all we got on the agenda for today is to talk about the quadratics assignment. We got ourselves that quiz tomorrow, and we'll finish out. We'll pretend tomorrow is our Friday, and that'll be our SEL day. Okay. Did anybody need another copy of the assignment? Okay, so we got a couple. Okay, so anybody else? All right, so let me go ahead and pull this up. I'll shut the door. Oh, it's recording it. All right, so let's see here. We want quadratics lesson. There we go. Okay, so what questions do we have? Number 3, right to it. Okay, so let's see. Oh, it's right there. If a is less than 1 and 2a squared minus 7a plus 3 is equal to 0, what's the value of a? All right. So basically, we just want to go ahead and find the root that's less than 0. Remember, the root is the x-intercept where it crosses the x-axis. Now, we've got a lot of different ways here. Primarily factoring and quadratic formula are probably at the top. I would go ahead and factor it. Now, because it's a general trinomial, I like my father drives a red Mercedes convertible. So it's a good opportunity to go ahead and run through those steps. Okay, so my father drives a red Mercedes convertible. Remember, the first letter of each word was a step in the process. So the first thing I'm going to do is take this 2, and I'm going to multiply it by some other number. What would it be? The 3. Okay, so you're going to multiply the first and the last numbers. So 2 and 3 give me 6. Now, whatever I choose to multiply to give me 6, they also have to add to give me a negative 7. So I know that my 2 numbers would have to be negative. Okay, what are the 2 numbers I'm looking at? It's got to be 6 and 1. We go. So negative 6 times negative 1, there's your positive 6. Add them up, there's your negative 7. Okay, so what did the D stand for? Okay, so we multiplied, we factored, the D in tries. We're going to divide. So in this case, we're dividing by 2. We always go ahead and divide by that leading coefficient. Okay, what about the R? Another word for simplify. Reduce, okay? So negative 1/2 will remain the same. Negative 6/2, remember we need both a fractional value for this numerator and denominator. So I'm going to simplify that to a negative 3/1. Now I want to move the numbers and create my 2 groups. Before I do that, I'm going to take my variable a, and I'm going to connect it to the denominator. And remember, we read these from the bottom up. So for example, negative 3/1a would be 1a minus 3. What about negative 1/2a? What would that look like? Say again. 2a minus 1. There we go. So that's great. I've now successfully got it factored. But how does that help me get the answers? What's that strategy we use? Zero product property. I'm going to take each one of these, set them equal to 0. So if a minus 3 is equal to 0, we've got a is equal to 3. If 2a minus 1 is equal to 0, okay, add the 1, divide by 2, we've got 1/2. Now, these are both solutions. They're values of a, but because a is less than 1, we're going to go with 1/2 here. Okay. What else? 1. So in the xy plane, what is the distance between the 2 x-intercepts for x squared minus 3x minus 10? Okay, so let's go ahead and figure out what the 2 roots are going to be. This one here, we can just probably go ahead and guess and check. What are 2 numbers that will multiply to give me negative 10, but those same 2 numbers will add to give me negative 3? we think here? Let's see, we're dealing with 10, so I only have 1 and 10, and I got 2 and 5. Okay, there we go. It's got to be a -5 and a +2. Of course, is this equal to 0? Just like we did a moment ago. If x minus 5 equals 0, x equals 5. And if x plus 2 is equal to 0, x equals -2. So if we're talking about the distance between these two, we'll just subtract them, but 5 minus -2 goes to addition. So how far are they apart? See, they are 7. Now, between 5 and 2, yes, but 5 and -2, we would have 7 units. Okay. 15. 15. Okay. For a manufacturer of x-ray machines, go ahead and get to this page here. The cost per unit in thousands of dollars can be modeled by the function f above, where x is the weekly number of units produced. How many units should the manufacturer produce each week to minimize the cost per unit? Okay, so there's one word that stands out here: minimize. Okay, so another word for minimum. Okay, what am I referring to? Well, that's a synonym. You're correct about that. But in context of a quadratic, when we say minimum or minimize, we're talking about one point in particular. Starts with a V. The vertex. Okay, there's something I need from the vertex. Now, how many units? That's what we're looking for, right? So what we have here, remember this particular function, the cost per unit in thousands of dollars can be modeled above, where x is the number of units. So when we're talking about this right here, all I need is the x value of the vertex. Okay. Now, there's a lot of different ways you could do this. I could go ahead and take this, complete the square, and put it in vertex form, but I think that's a lot more work. Does anybody remember that little expression that will immediately give me the x value of your vertex? You do something with A and B. So you want to put it in vertex form? Yes, that little expression. Okay, so does this look familiar? The opposite of B over 2A? Okay. And then if I wanted the corresponding y value, I would plug that back into the function. So remember, if you have standard form, here we know A is 1, B is -24. If I have those, I can immediately find out what the vertex is. Okay. But completing the square would do the same thing. Would require a little more work, but it's going to get you there. All right, so all I want is the x value, which means this one right here. So let's see. B is a -24. Okay, what I want is the opposite of B, so that's going to be a +24 over 2 times A. Well, A is equal to 1. So it looks like 12 units is going to minimize the cost per unit. All we wanted to know was the number of units, which is x. Okay. Everybody okay on 15? Okay. Let's try 10. What's 10? Oh, wow, I got a lot of stuff on there. Let's not erase that. Okay, so there we go. Just kind of forget about that. La, 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 la. Looks like I put that in vertex form. Yep. Anyway, for what value of t does the equation v equals 5t minus t squared result in the maximum value? Okay, so if we're looking at an ordered pair for any point that would appear on this, okay, you're going to have t comma v. Okay, so whatever t you put in, the v is going to be dependent on that. Now, we're looking for the value of t that results in the maximum. So this is the same type of problem that we were just looking at. Okay, minimum, maximum, in context of a quadratic, we're talking about the vertex. Now, even though it's asking for the value of t, it's really wanting what? If we go back to the original variables. Oh, not y. X. They wanted x. Okay, so in this case, x represents your t, y would be your v. Y is the dependent variable. Okay, well, if all I'm looking for is the x value of the vertex, what was that little expression that I could use? Negative b over 2a. Okay, I've got my standard form right here. I see that a is equal to -1. Remember, a is the coefficient of your square term. Doesn't matter what the variable is. And b is equal to 5. Okay, so let's go ahead and plug this in. So the opposite or negative of b, that would be -5 over 2 times -1. So it looks like I'm going to have +5/2. Or if you wanted to convert that to a decimal, I could go ahead and say 2.5. Okay, so that should give me the corresponding y value in this case, which would be the maximum. Okay. Any questions on this one? No? All right, what's 11? 11. Okay, P equals M squared minus 100M minus 120,000. So the monthly profit of a mattress company can be modeled by the equation above, where P is the profit in dollars and M's the number of mattresses sold. Okay, what is the minimum number of mattresses the company must sell in a given month so that it does not lose money during that month? Okay, now this one's kind of different than the others. We're talking about profit versus the number of units sold. So if we want to go ahead and, like it said here, so it doesn't lose any money, basically that means where we're going to break even, where we're going to go ahead and hit the x-axis. So it's the roots on this one that I'm really interested in. Okay. Now there's 2 ways we could do this. We can factor it, but I'll tell you, it took me about a minute to go ahead and run through. We heard something, right? No? Maybe it was just me. Okay. Took me a few minutes because this 120,000, that's a large number. So I was looking for 2 factors in particular that'll multiply to give me that, but also multiply or add to give me -100. It does work. Okay. So unless anybody knows them right off the top of your head, maybe this is one we want to use the quadratic formula. No, not 50/50, because 50 times 50 won't give me 120,000. No. I'll tell you what, at the end, I'll tell you. Well, I'll let you know so you can reconcile that. Okay, so what is the Pythagorean theorem? What am I talking about? The quadratic formula. What does x equal? So I got this big formula here. Starts off with the opposite of what? Opposite of b, plus or minus the square root. What's inside here? Close. We're going to subtract a 4ac, but from what? A squared, okay? And then all of this is divided by 2a. Now, even though we have the variable m, doesn't change a thing. We still see that a is equal to 1, b is equal to a -100, and then c is equal to a -120,000. So that part of the screen is kind of messing up, but that's supposed to be -120,000. Okay. Well, let's go ahead and start to plug everything in. I would go ahead and find this first. Now, remember, we talked about this earlier this week and last week. Does anybody remember what we call b squared minus 4ac? Big word starts with a D. That's the discriminant. There we go. Okay. So let's see what we're going to get out of that. So we want b squared. So this is going to be a negative 100 squared minus 4 times a, and then times c. So that's going to be a negative 120,000. Okay, so let's come on over here to my calculator, which unfortunately I don't have pulled up yet. Okay, so bear with me for just a few seconds. Yeah. Oh, actually, Tenzin asked first, and then you'll be after him. Yeah. Okay, so let's see here. All right, so we had a parentheses negative 100 squared minus 4 times a times c negative 120,000. Okay. All right, so my discriminant, I'm getting 490,000. In fact, because it's positive, how many real roots should I have? 2, 1, or none? Should be 2. If the discriminant is positive, you got 2. If the discriminant is 0, you have 1. And if the discriminant is negative, there's no real, but it's what? Imaginary. There we go. So 490,000. Let me come on back over here. Okay. So let's see here. We now have x equals the opposite of b, 100, plus or minus the square root, 490,000. And we're all going to divide this by 2 times 1, so just 2. All right, so let's see what we end up with. I need to know the square root of 490,000. Okay, so it's going to give me 700. Okay. All right, so that was interesting. So x equals, we have 100 plus or minus 700 divided by 2. So these are going to give me the roots that you were looking for just a few moments ago. Now, how am I getting 2 answers out of this? Yeah, the plus minus. Okay. So for one of these, we'll go ahead and say this one's the plus. So 100 plus 700, that's 800. Divided by 2. So your first root is 400. And then the other one, let's go ahead and subtract that. So 1 minus 700, that's going to be a negative 600. Divided by 2, so my other root is a negative 300. Okay. So what you would have used if you were going to factor it, you would have had a negative 400 and a positive 300 because you needed a negative 100 for your linear coefficient. Okay. Now, we're talking about number of matrices here, right? Does one of those answers not make sense? You're not going to have negative 300 matrices. Okay? We don't think about quantities and negatives in the real world. So because we have to eliminate that one, this is the answer I'm looking for, 400. Okay. All right, so we should sell 400 in a given month so we don't lose any money. But that's where we, according to the graph, would break even. So we want to sell more than 400 to go ahead and start getting more money. Who asked about this one? Does that make sense? Okay. Were you close? Okay. All right, what else? 4. Okay, so it says, what's the sum of the solutions of 2x minus 3 squared equals 4x plus 5? Now, we don't have the standard form just yet, so we need to go ahead and do a little bit of algebra first. So we're going to expand this group right here. Okay. Now, it's been a while, but it's a perfect opportunity. Does anybody remember that rhyme that I gave you? So first we square the left. Okay. So 2x times 2x. 4x squared. Square the right. So negative 3 squared, that's going to be a plus 9. And then we double the middle. So that means 2x times negative 3, and then we double it. So that would be minus what? 12x. Now, even if you expanded 2x minus 3 and FOILed it, you're still going to get the exact same thing. We squared the left, we squared the right, we doubled the middle, got it right. Okay. Or answers inside, however you want to say it. Now, this equals 4x plus 5. All right, so let's go ahead and clean this up a little bit. Let's bring everything to the left side. 4x squared, if I subtract 4x, that'll give me a negative 16x. And 9 minus the 5 will give me plus 4 is equal to 0. Now, do you notice anything about this particular quadratic? The door was open? Yeah. Okay. We notice anything about this particular quadratic, like the values of a, b, and c? We can simplify if we want to. Okay, if I'm looking for the roots, that's perfectly fine. Okay, now if I wanted to know the vertex, I wouldn't simplify. So I can say, okay, let's go ahead and divide through by 4. That would be x squared minus 4x plus 1 is equal to 0. Okay. Now we could go ahead and find the roots, but remember, part of the lesson was using shortcuts. We had these two shortcuts here. The opposite of b divided by a and c divided by a. One of those would immediately tell me what the product of my roots are. The other one's going to tell me what the sum of my roots are. Which is which? C over a is the sum? We're very close. There we go. So this one right here is the sum. This one right here is the product. So I don't even need to work through as long as I have the values of a and b that I need. I see that a is equal to 1. I see that b is equal to a negative 4. So let's go ahead and plug it in. The opposite of b over a, well, that would be positive 4 over 1. So whatever my two roots are, if I were to add them up, I should be getting 4. Okay, how are we doing? Anybody want me to actually find the roots and then just show you if we add them, we're going to get that? No? Okay. Bless you. All right, what else? Good questions this time. Good questions. Oh, here comes another one. Bless you. Any other questions? Oh, you want a Kleenex? You sure? Okay. Grayson, you want to do number 6? Okay. All right. So we have f of x equals m, and then inside brackets x minus m squared minus 1. If the function f defined above, m is a positive constant. The graph of f in the xy plane is a parabola. Which of the following statements about the parabola is true? Okay, so the minimum is m negative 1. The minimum is m negative m. The maximum is m negative 1, or the maximum is m negative m. See, all your answers, it's either the maximum or the minimum. What does that mean when we're talking about a quadratic? Vertex. And you'll notice, what form is that in? It's in vertex form, yeah. Now, except for one thing. Remember, this was vertex form right here. A times x minus h squared plus k. There's one thing I have to do, and it's going to be in vertex form. Does anybody see it? I got to get rid of the brackets. The only way I'm going to get rid of the brackets is to multiply. Okay. Well, let's take a look. If I do that, I'm going to get m times this group, x minus m squared. And I can't distribute across this group because of the square. The square's kind of protecting it. But then I'm going to have minus m. Okay, so can anybody tell me what direction would this parabola open? Would it open up or down? Why up? There we go. It does tell me that m is positive, right? So our parabola is going to be opening up. That means our vertex, does it contain a maximum or a minimum? It contains a minimum. So knowing that, those two are already gone. Now remember, compare it to our vertex form. This is our H, this is our K. Now for the H, we always take the opposite. So that means instead of minus m, we're going to have a positive m. Okay. And for the K, we leave it as is. So it'd be minus m. So which one am I looking at, A or B? It is B. Did anybody do that a different way? And you have a...
I came from my agriculture. I have a floral certificate.
Okay.
Thing, so it should be in my attendance.
All right, we're just working on the assignment. Did you need a copy? There you go. All right. Grayson, is that good? Were you thinking about B or were you close? So? Okay. All right. What else? So we feel good about quadratics going into that quiz tomorrow? Well, the annoying ones are the ones that make life worth living. They're super fun. All right. Well, we are done. I don't suppose anybody was ready to turn in the assignments. Probably hang on to it till tomorrow. Okay. All right.